Imagine an electric car so efficient that it squeezes out an extra 200 miles of range. Not because of a bigger battery, but because of a smarter motor. A motor that's lighter, smaller, and more powerful than anything we've seen in mainstream EVs. That's the promise of axial flux motors, and if Aptera ever adopts them, it could completely redefine how we think about electric vehicle performance and efficiency. Hey everyone, welcome back. Today, I want to talk about something I stumbled upon that absolutely blew my mind: axial flux motors. Maybe some of you already know about them, but for me, this was a brand new rabbit hole. And once I started learning about how they work, and how they could fit into vehicles like the Aptera, I realized just how revolutionary this technology could be for the future of EVs. So, in this video, let's unpack what an axial flux motor is, how it compares to the traditional design found in most electric cars, and why it might just be the perfect match for ultra-efficient vehicles like the Aptera. Trembling. Let's start with what we already know. Most electric vehicles today use what's called a radial flux motor. In a radial design, magnetic flux, which is basically the invisible magnetic energy that makes the motor spin, flows outward, from the center of the rotor to the stator, like spokes on a wheel. It's a brilliant system and incredibly refined. Tesla's Model 3, for example, uses one of the most advanced radial flux motors ever built. It's powerful, efficient, and reliable. But it's not perfect. Every design has its limitations. And in the case of radial motors, weight and energy loss are two big ones. Now, here's where axial flux motors turn the story on its head, quite literally. Instead of the magnetic flux moving outward in a circle, it moves along the same axis as the rotation of the motor, hence the term axial. In simpler words, the magnetic field flows parallel to the shaft instead of radiating out from it. And that small directional change makes a massive difference. In an axial flux design, the motor's stator, the part that generates the electromagnetic field, is sandwiched between two magnetized rotors. This compact pancake structure eliminates the heavy metal yoke that radial motors need, dramatically reducing the motor's overall weight. Let's talk numbers for a second, because this is where things get really exciting. Magnax, one of the leading companies developing axial flux motors, compared their yokeless design to Tesla's Model 3 motor. The Tesla unit weighs around 46 kilograms and delivers roughly 238 kilowatts of peak power. The Magnax motor, on the other hand, weighs under 25 kilograms, almost half the mass, while delivering up to 400 kilowatts of peak power. That's a four-fold increase in power density, 4 times more power for every kilogram of motor weight. That's a staggering leap in efficiency and design, the kind of jump we rarely see in mature engineering fields like electric drivetrains. And it's not just about power. These motors also use 74% less copper, 50% less iron, and 26% less permanent magnet material. That means they're cheaper to produce, lighter to ship, and more sustainable to build. For a company like Aptera, which is all about efficiency, lightness, and eco-conscious design, this kind of motor isn't just interesting, it's potentially game-changing. Now, let's talk about range, the holy grail of EV design. According to Magnax, their motors can achieve 96% efficiency. To put that in context, most high-end radial flux motors, including Tesla's, operate somewhere around 88 to 90%. That may not sound like a huge difference on paper, but in real-world driving, it translates to up to 20% more range, without adding a single extra battery cell. For an ultra-efficient vehicle like the Aptera, which already promises around 1,000 miles of range on a full charge, that could mean an additional 100 to 200 miles. That's not just impressive, that's unprecedented. Fishing efficiency aside, The form factor of an axial flux motor is another huge advantage. Because the design eliminates the yoke and reduces the air gap, the tiny space between magnets and coils, the result is a smaller, thinner motor that still delivers incredible torque. In fact, some prototypes show up to 3 times the torque density compared to equivalent radial designs. Insulation. This compactness opens new doors in vehicle design. Imagine an Aptera with smaller, lighter hub motors directly integrated into the wheels, not only saving space inside the vehicle, but also improving aerodynamics and overall mass distribution. That's the dream. Less mechanical complexity, fewer moving parts, and higher overall system efficiency. There are 2 companies leading the charge, Magnax and YASA. Magnax recently spun off a division called Traxial, focused entirely on commercializing these yokeless axial flux designs. Their data suggests 3 times the power density and 20% more range for EVs that adopt them. Missionary. YASA, which was actually acquired by Mercedes-Benz, is taking a more conservative approach. Their axial motors reportedly offer around 30% higher power density and a 5% range improvement. Both are promising, but Magnax's vision aligns more closely with ultra-efficient EVs like the Aptera. Michelle. During these where things get really interesting. Aptera's current hub motors, the Elafe M700s, already make it one of the most efficient vehicles ever designed. Each motor adds about 23 kilograms of unsprung weight to the wheels. But imagine if those motors were replaced with axial flux versions. If the power output stayed the same, but the motor weight dropped to 1/3, around 8 kilograms per wheel, the impact would be massive. Less unsprung weight means better ride quality, improved handling, and less strain on suspension components. Combine that with the potential 10 to 20% range boost, and the 1,000-mile Aptera could suddenly stretch to 1,100 or even 1,200 miles per charge. That's more than most gasoline cars can travel on a single tank. Of course, as exciting as this sounds, we have to stay realistic. Axial flux motors are still a relatively young technology. Manufacturing them at scale, ensuring long-term durability, and integrating them into mass-market vehicles will take time. Even the most optimistic forecasts suggest 3 to 5 years before we see axial flux motors in mainstream EVs, and even longer before hub-mounted versions become common. But that's the trajectory of innovation. It starts as a niche idea, gets refined through testing, and eventually reshapes the entire industry. Think back to the early days of lithium-ion batteries. They were once expensive, fragile, and impractical for cars. Now they're the backbone of the electric revolution. Axial flux motors could follow the same path. Aptera, more than any other vehicle, seems built for this technology. Its entire design philosophy centers around lightweight efficiency, minimal drag, minimal mass, and maximum range. An axial flux hub motor complements that vision perfectly. It would make the drivetrain simpler, lighter, and potentially even more efficient than today's system. It could also free up design space for more solar cells, better suspension geometry, or a larger interior battery, without sacrificing performance. If any company is going to pioneer an axial flux hub motor setup, Aptera is a top contender. Beyond Aptera, axial flux motors could reshape the entire EV landscape. By delivering more torque per kilogram and reducing material needs, they make smaller, cheaper, and more efficient EVs possible. They could even extend to electric motorcycles, aircraft, or robotics, where space and weight are critical. And because they require less copper and rare earth material, they also make the EV industry more sustainable and scalable, reducing dependence on supply chains that are currently under pressure. So, will Aptera use axial flux motors in its future models? It's too early to say. But one thing's for sure, the technology is advancing fast, and the potential is enormous. We're looking at motors that are lighter, more efficient, and dramatically more powerful. And that could translate to cleaner, longer-range electric vehicles across the board. Even if it takes a few more years before we see axial flux hub motors on the road, the progress being made today is laying the foundation for the next generation of EV innovation. And when that day comes, vehicles like the Aptera, designed from the ground up for efficiency, will be ready to take full advantage. What do you think? Could axial flux motors become the new standard in EVs? And would you love to see them in the Aptera? Let me know your thoughts in the comments. I'd love to hear your take on this fascinating technology.